Alright, so in this video we're going to look at second order ordinary differential equations. Right, this starts our second order stuff. So in this video we're going to look at homogeneous equations with constant coefficients. So for second order, we're going to have a new standard form for our second order equations. Right, so for first order we had what was it? It was like a of t times x prime plus b of t times x is equal to c of t, right? Now for second order, which is what we're focusing on now, we're going to have something like this. A of t times x double prime plus b of t times x prime plus c of t times x is equal to s of t. Okay, so now, however, because it's homogeneous equations for this section, we are going to set S1 S of t is 0. So in this section, all of our problems are going to be in this form. Right? Because that's a homogeneous equation. It equals 0. So now, what the idea is for these second order homogeneous equations with constant coefficients, these coefficients right here are constant. These are constant coefficients. So the idea with these is we're going to propose something. You're going to notice that a lot in the second, when we get into higher order stuff, we're going to do a lot of proposing. So we're going to propose x is equal to e to the rt. So then from there, x prime is re to the rt, and x double prime is, what's that, r squared e to the rt? Right? So the idea then is we just propose this. This doesn't come from anything. You can just, I don't actually know where it comes from, but this is just part of the process of, you're going to notice this a lot in second order. So what we're going to do now is you're going to replace x double prime, x prime, and x back into our form here. So we have I'm just going to call this a times x double prime plus b times x prime, which is re to the rt, plus c times x, which is e to the rt. And of course, equals 0, because it's homogeneous, right? So now you'll notice that we can cross out all these e to the rt's, right? Because it's in every single term. So now we're left with ar squared plus br plus c is equal to 0. So that's the general idea for these. And then with this answer right here, this will be our, we would then use this, we would then solve for r. Okay, so step 1 is to propose. Step 2 is to substitute. And step 3 would be to solve for r. So let's just go right into an example, just so I can show you what I mean. So as you can see, we're given this second order equation. And that's homogeneous, right? So for this problem, we're going to propose. So step 1, right? Propose. propose x is equal to e to the RT. So then x prime is r e to the RT. X double prime is r squared e to the RT. Step 2, substitute. Oh, sorry. They give us y in these problems, right? So this is not x, it's y. So I'm going to plug in for y double prime. Yeah, r squared e to the RT plus 2 times r e to the RT minus 3 e to the RT. Now, after you get good at this stuff, for all of these questions, e to the RT is going to cancel out every single time because it's homogeneous. It's going to be in every term, and it's going to cancel out every single time. So if you want to, you can take a shortcut and just not even write down the e to the RT. But I just want to do it in these examples just to show you what happens here. So we're left with r squared plus 2r minus 3 is equal to 0. So now from here we can factor this out, right? So this would be r minus 1 times r plus 3, right? Equal to 0. Yep, that works. And then so then r is equal to 1 or negative 3. So now what this means, when we write our general solution, so step 4 would be our general solution. So we're going to have most likely r1 and or r2. So what that means, when we propose a general solution, it's going to look something like this. C1 e to the r1t plus c2 e to the r2t. So that's our general solution. So if I come down here, keeping that in mind, come down here now, we can say this is our r1, this is our r2. Our general solution will then look like c1 e to the r1 times t, so that's 1 times t, plus c2 e to the negative 3t. And this is our general solution. That's it. Not so bad, right? These homogeneous ones are pretty straightforward, pretty simple. Just that proposing y, the only thing you have to memorize is the propose e to the RT, right? We know that, so what that comes from is we know y is equal to e to the RT, right? That's where that general solution, this is where this formula here comes from. Y is equal to e to the RT, but in this case we have two r's. So we have to add together both of those terms there. That's all it really is. The c's, I'm actually not sure where they come from, but maybe we'll find out later on when we get deeper into second order. So now let's go on to the next example. This one's very similar to the first one. Same exact process. 6y double prime minus y prime minus y is equal to 0. So step 1. Excuse me. Propose x is, we have y. Y is equal to e to the RT. Y prime is equal to r e to the RT. Y double prime is equal to r squared e to the RT. Step 2, substitute. 6r squared e to the RT minus r e to the RT minus e to the RT is equal to 0. E to the RT's cancel. We're left with 6r squared minus r minus 1 is equal to 0. Okay, for this one, oh man, if you use quadratic formula, right? We can't factor that out nicely. You have to complete the square or use that quadratic formula. I actually prefer to complete the square, but I'm forgetting how to do that at the moment, so I'm just going to play it safe and use the quadratic formula. So for this one, it's what, b, so, well, negative b, so 1 plus or minus the square root of negative 1 squared, right, minus 4 times 6 times negative 1 over 12 is equal to r, right? So now we're going to be left with, let's see, 1 plus minus the square root, that's 1, minus 4 times 6 is 24, times negative 1, so that's plus 24, over 12. So then r is equal to 1 plus or minus the square root 25 over 12. R is equal to 1 plus or minus 5 over 12. So then r is either equal to 6 over 12 or 1 minus 5, so that's what, negative 4 over 12. So that, excuse me, so that leaves us with r being either 1/2 or r being, what's that, negative 1/3. Okay, so now that we have our r's, this was step 3, right? Solve for r. Step 4, general solution. I forget to write step 4. Oh, that's all right. Step 4, the general solution. Y is equal to C1. Now, it doesn't matter which one you write first. It doesn't matter. Both C's are arbitrary. It doesn't matter which C1 goes with which R. It does not matter. It does not matter. 1/12 just T plus C2 e to the negative 1/3 T. All right, now the next one. This is our answer here. That's our general solution. Okay. The next one, you're going to notice we have no y prime for this one. So we have 4y double prime minus 9y. And there's no y prime. It doesn't matter. So you just still do the same thing. We still are going to propose x is equal to e to the rt. X prime, sorry, I keep doing x, that's why. Y prime is equal to r e to the rt. Y double prime r squared e to the rt. Substitute. We have 4r squared e to the rt minus 9 e to the rt is equal to 0. These cancel. 4r squared minus 9 is equal to 0. So solve for r for this one's pretty simple, right? So we have 4r squared is equal to 9. R squared is equal to 9 over 4. R is equal to the square root of 9 over 4. So then r is equal to 3 over 2. Nope, that was step 3, solve for r. Step 4, general solution. So for the general solution, plus or minus, right? So then our general solution is y is equal to c1 e to the 3/2 t plus c2 e to the negative 3/2 t. And this is our general solution. Now, I'm going to go ahead and get a few more problems. I'll be right back. Okay, so I went ahead and got 2 more problems. So, like before, we had our general solution had C1 and C2 in it, right? Well, now we're going to look at some problems that have initial conditions. So with these initial conditions, it's going to allow us to solve for C1 and C2, and we're going to have a general solution without any constants, right? So we're not going to worry about sketching, because that would require a calculator, because that's what this G means. This G means it's like a calculator problem. So we're just going to skip out that calculator section. Okay, so let me rewrite this. Y double prime plus y prime minus 2y is equal to 0. So we're still going to solve this the same way we normally would, right? So then we have excuse me. We propose, step 1, propose y is equal to e to the rt, y prime is equal to re to the rt. That's an r, it looks like a v. Y double prime is equal to r squared e to the rt. Substitute r squared e to the rt plus re to the rt minus 2e to the rt is equal to 0. These cancel. R squared plus r minus 2 is equal to 0. We can factor this one out nicely. That'll just be r plus 2 times r minus 1 is equal to 0. So r is equal to negative 2 and r is equal to 1. Right, so now our general solution, that's actually step 4, right? Y is equal to c1 e to the negative 2t plus c2 e to the t. Okay, so now we're given two initial conditions, okay? So let me, so we have y naught, y of 0 is equal to 1. We have y prime of 0 is equal to 1. So for both of these two cases here, we're going to have, for this one, we'll have 1 is equal to c1 e to the 0 plus c2 e to the 0. And these just become 1, right? For this one, we have to take the first derivative. So we have to actually find y prime, right? So like we'll have this will be negative 2 c1 e to the negative 2t plus c2 e to the t, right? And then you can plug in our initial condition. So then we'll have 1 is equal to negative 2 c1 e to the 0 plus c2 e to the 0. These become 1. Here, we need another page here. So then we're gonna have two equations now. So we're gonna have 1 is equal to c1 plus c2, and we're gonna have 1 is equal to negative 2c1 plus c2. So if you notice here, we have two equations, two unknowns, right? And so with these two equations, two unknowns, we're able to solve for c1, c2. So we can either use substitution, elimination. If you've taken linear algebra before, you can use a matrix. So I'm gonna do I'll do elimination, right? So if we subtract this first equation from the second one, that'll be, what was I doing? If I multiply this whole equation by negative 1, and I add it to this row, or I'm thinking of matrices here, but I'm just doing elimination. We'll be left with 1 is equal to c1 plus c2, and this row would become 0, negative 3c1, yeah, plus 0. So then from this, we can already see that c1 is equal to 0. So this is elimination. I'll do a substitution too. So c1 equals 0. So then if c1 equals 0, then 1 is equal to 0 plus c2. I just got that from this. So then c2 is equal to 1. Okay? So then we can go back to our general solution, and we can plug in for c1, c2. So y is equal to 0 e to the negative 2t, 0, plus 1 e to the t. So just e to the t. And this is our solution. This is our general solution to the IVP. This is an IVP problem, right? Okay, so now let me show you how to do it with substitution really quick. So I can solve the top equation there for C1 is equal to 1 minus C2. Plug that into the other one. 1 is equal to negative 2 times 1 minus C2 plus C2. Simplify negative 2 plus 2C2 plus C2. 1 is equal to negative 2 plus 3C2. That's 3 is equal to 3C2. C2 is equal to 1. C2 is equal to 1. We go back to here, and then we do C1 is equal to 1 minus 1. C1 equals 0, right? So that's the other way you can do it. One more problem. So this one doesn't have a y in it, so this one will be a little bit easier, I think, to solve for r. So let's step 1. Propose x is equal to e to the rt. X prime is equal to re to the rt. X double prime equals r squared e to the rt. I did it again. Those should be y's. Okay, so now substitute, right? R squared e to the rt plus 3 r e to the rt is equal to 0. These cancel, and we're left with r squared plus 3 is equal to 0. So this tells us that r I was going to say that doesn't work. I forgot the r there. So if we take out an r, this would become r plus 3. So then we're left with r is equal to 0 and r is equal to negative 3. So now y is equal to, if 1r is 0, e to the 0 is 1. So we just have we have one constant here plus C2 e to the negative 3t. Yep. Okay, so now we once again have our two initial conditions. So first of all, right from here, let's just solve for y prime since we're going to need it later. So, excuse me. So y prime would just be, since C1 is a constant, it'll become 0, right? So this will be 0 plus, well, minus 3 C2 e to the negative 3t. Right, so now I'll just get rid of that 0. So now, let's use our initial conditions. We have y of 0 is equal to negative 2. So that is negative 2 is equal to C1 plus C2. E to the 0 is 1. So then this is our equation. We also have y prime of 0 is equal to 3. So then that's 3 is equal to negative 3 C2, right? So now we have two equations. Oh, this one's a lot simpler because right here we can get C2 very easily. C2 is equal to negative 1, right? So then, we can do substitution very easily for this one. This is C1 minus 1. So then C1 is equal to negative 1. So they're both equal to negative 1, it looks like. So now let's plug in. Our general solution is up there. Let me mark this. So then we just plug this back in. C1 is -1, C2 is -1. You can get rid of that. So then this is our general solution. So second order homogeneous is very simple, right? Just have to remember what to propose, and you get the hang of it, right? So, but after we get going with the second order stuff, it does get a little more difficult as we go on. Once we get into non-homogeneous second order, non-homogeneous get very complicated and very long. It's not that they're necessarily complicated, but they're just very, very long. I mean, like a whole page of work. So it's really important to get really good at this earlier stuff, get your foundations down, get used to like substitution, get used to algebra, review all your algebra techniques, review completing the square, review quadratic formula, and that'll make your life a lot easier for the upcoming sections. So I hope you enjoyed the video, and in the next section we're going to take a look at the Vronsky.